Hello, we are doing showcase number 2 for pre-calc. I have my St. Patrick's Day stuff on because my St. Patrick's party is tonight, not last night, because I'm a good student. Um, so let's get into this. So we have this Ferris wheel problem, and we're given our diameter is 30 meters, its center is 18 meters above the ground, and it makes one complete revolution every 60 seconds. Assuming the rider starts at the lowest point, complete the following. So we're going to sketch a graph, a sine graph that represents what all of these things mean. So I did my work separately, not on here, and I'll walk through how I got all of my values. So the first thing I see that um, I think the best key point here is the center being 18 meters above the ground. So it's telling you that's the midpoint. So that was the first thing I plotted on my graph. And we know that the diameter of the Ferris wheel is 30 meters, which means that it has to go 15 meters above the midpoint and 15 meters below the midpoint. So 18 minus 3 gets you 15 meters here. So our low point is 3 meters, and our high point would be 18 meters plus 15 meters, giving you 33 meters. So now we know our low point, our midpoint, and our high point. So the graph is starting to come together. The question also tells us that one revolution every 60 seconds. So we're going to plot time on the x-axis. And we know that one full cycle, as described here, will be 60 seconds. So we're going to have a full rotation of the Ferris wheel at 60 seconds. And so you can infer from that 30 seconds in, you'd be at your high point, and the second cycle would start, and 90 seconds, you'd be at your high point. So you're going to obviously start at your low point because that's how you get on the ride. And I highlighted this section here because that is what is going to help me create an equation. Since the first part of this, if you look at just from the start to the 60 meters, it looks like an inverted cosine graph, but we're told to graph it as a sine function and then convert it to a cosine function. So I jotted down some notes here. So like I said, the diameter is 30 meters given an equation, so that gives you 15 meters, so you can get your total height. The phase shift is 15 seconds, and how we get that is, if you look at the graph, you're going to plot your 5 points at the beginning, the apex, and then as it descends again to its low point. And those 2 points in the middle is going to be where it crosses your midline. And you'll notice that it's kind of passing all of these key points every 15 seconds. So halfway between 30 and 0 seconds is 15 seconds. So you're going to end up with your point here at 15 seconds and 18 meters, and here would be 45 seconds and 18 meters, 75 seconds and 18 meters, and 105 seconds and 18 meters. And we know so we already went through that. So we know our vertical shift. We can think of a vertical shift as basically wherever the midpoint is. So that's going to be 18 meters. Our amplitude is going to be, how high we go above our midpoint. That's 15 meters. To do the equation, we'll also have to figure out the period, and the period for a sine function is 2 pi over b. So you come to a b value of pi over 30. So now when we put together our equation, we're going to start with y equals, and then we set our phase shift as 15 because we need to start where a sine graph actually starts, which is this function right here. You can see it's pushed to the right by those 15 seconds. So, and our amplitude is 15 as we described earlier. So we're going to have 15 sine pi over 30, which is our period. and then that's going to be multiplied by x minus 15. The minus 15 because the phase shift to the right of 15 seconds, and then a vertical shift of 18, which is our midpoint. So we're left with this for our sine equation. Now for cosine, it's rather easy since you're not really doing any calculations. What we're doing is essentially flipping our sine graph and taking out its phase shift, because at cosine we're going to start. This is a cosine graph, right? So by purely just flipping it over the x-axis, just giving a minus sign out front to the sine graph, we'll be able to create our cosine function. And then, like I said, there's no phase shift in this part for a cosine graph. It's like a perfect cosine graph, right? So all we're doing is getting rid of that 15 seconds. We can bring our pi over 30 in over here to x, since it's not going to muck up a phase shift. And then our midpoint is still the same. Our vertical shift is unchanged, so that's plus 18. So there you have it. Happy St. Patrick's Day.